Hello student, welcome to my class. In the last few classes we have discussed about the solving of quadratic equation. Now today we will go through the nature of the roots of the quadratic equation. Last class we have discussed by applying the quadratic formula. In that one we got the discriminant, and that's from there we can get the nature of the roots also. What type of root will be for a quadratic equation? Now this quadratic equation, we can take the standard form of this equation. Suppose ax square plus bx plus c equal to 0, where a not equal to 0. For this case we know discriminant d equal to b square minus 4ac, and the roots are given by alpha, two roots. Suppose alpha equal to minus b plus root d by 2a, and beta equal to minus b minus root d by 2a. These things we got in the last class, also we have discussed that. From there, if we want to see the roots of the equation, what type of root it will be. Suppose d, that is b square minus 4ac. Case wise, if we think, if d is greater than 0, that means b square minus 4ac is greater than 0. So that's will have particular value. That is also real number. That's root d, that is also real number. So numerator is defined, here also numerator defines 1. So roots are real and distinct, and the each root will be, that root will be given this minus b plus root d by 2a and minus b minus root d by 2a. So if d is greater than 0, any positive value if you get, then the roots will be what? Real and distinct. Distinct means different, means unequal. Now second case, if d value is equal to 0, if it becomes 0, so root 0, 0, minus b plus 0, minus b minus 0, both will be the same. Therefore, we can say the nature of the roots becomes, roots are real and equal. Therefore, both the cases roots are real. Only real if you say, then either it will be greater than 0 or equal to 0. That's why d is greater than equal to 0, we can say, then we can say roots are real. And third, another case you may get, that is third one, you can say d is less than 0, any negative value it has come. Then what it will be? Roots will be not real, or roots are not real. So three cases we are having. If d is greater than 0, then roots are real and distinct, means unequal. These roots will be minus b plus root d by 2a, minus b minus root d by 2a. If d equal to 0, then roots are real and equal, and each root will be equal to minus b by 2a, because root d equal to 0. And third case you will have, if d is less than 0, then the roots will be not real, or you can say imaginary. Now that's one we can see in the table form. What's the value of d, or that's from there what's the nature it will have. A simple table, if we remember, if we see, then we can go through that one also. In this one, in the equation ax square plus bx plus c equal to 0, a not equal to 0, and d you know, b square minus 4ac. On the value of d, that's roots will be dependent. That means if you make the table, suppose that's value means d value, and then nature of the roots, and then the roots, what type of roots you will get. First case you can get d is greater than 0, any positive value. Then nature of the roots will be real and unequal or distinct, जो भी बोलो. And the roots will be two root, that is minus b plus root d by 2a, and another root beta will be minus b minus root d by 2a. Second case, if d equal to 0, that means roots will be real and equal, and the roots are given, both the roots are equal, that means each root will be equal to what? Minus b by 2a. And third case, if you have d is less than 0, negative value if you have, then roots will be what? Nature of the roots will be not real, or you can say imaginary, and that's why you can't find out the roots. So these are the, on the basis of the value of d, we can decide, we can discriminate what type of root it will have. Now some question, if we check, if we see, then we can get the types of root, or we can find out some unknown if the conditions are given. See, first question, suppose you are having one question, you find the nature of the roots of the quadratic equation. Find the nature of the roots of the equation is given to you 4x square minus 5x plus 3 equal to 0. The given equation is always compared with the standard form. So the given equation is in the form of 4x square minus 5, form of ax square plus bx plus c, standard form के साथ compare करो, ax square plus bx plus c equal to 0, where a equal to what? A equal to 4, b equal to minus 5, and c equal to 3. So all these three values you got, a equal to 4, b equal to minus 5, c equal to 3. So therefore from there you can get d equal to, b square minus 4ac. So what it will be? Minus 5 square minus 4 into 3. So ultimately you see 25 minus 48. Means what it is coming? Minus 23. Anything it can be, but that is coming minus. Minus means what? Less than 0. If the d is less than 0, then what type of root you will have? We have what? The condition is saying if the d is less than 0, so we can conclude that the roots are not real. So from there we can find the nature of the roots. From this, if d is equal to 0, then it will be, roots will be real and equal. Now next one, if we want to go, suppose some unknown is having. For that you have to find out the value of k, or like that one, that to be decided. One question, see next one. Suppose the given equation is having in the form of find the value of k. Find the value of k, find k, just I am writing, for which the roots of the equation that is what? Kx into x minus 2 plus 6 equal to 0 are equal. Its roots are equal, that to be find out. So that standard form of that equation, if we convert, then you will get kx square minus 2kx plus 6 equal to 0. So it is in the form of ax square plus bx plus c equal to 0. So where a equal to what? If we compare with the standard form, then a equal to k, b equal to minus 2k, and c equal to 6. Therefore from there you will get d equal to b square minus 4ac. So minus 2 ka whole square means ultimately 4k square, or minus 4ac minus 4k into 6. So 4k square minus 24k. That is d. And for real and equal roots, what to be the condition? What the condition for the equal roots? We know that for equal roots we have d equal to 0. Here d means 4k square minus 24k equal to 0. If you get common 4k, so it will be k minus 6 equal to 0. So from there we are getting k equal to 0 and k equal to 6. Now you have to check both the values are possible or not. So for k equal to 0, it is coming that from there if you put that equation k equal to 0, so 0 plus 6 equal to 0. So for k equal to 0, we can say for k equal to 0 we have 6 equal to 0. That is the absurd value, which is not possible. So for equal root, k should be what? K should be 6. In this way, we can start, we can do that one. So now, in the very beginning, we will practice that one. Few questions you will practice. That is, you are having what? In the exercise, you will start up to question 10, 1 to 10 of 4D to be practiced. Okay? You will do that one. Then next class, we will do the next one.